All right. So in this particular case, we'll create another example. It's a simple web app. We create a file, simple Sinatra app. It's also Ruby, like a Rails app, but similar, simple, comparable to the Go app. So yeah, it's requiring Sinatra. It creates a URL, and mounts to the URL, to the root URL, and prints hello world as a heading. Ruby simple Sinatra. If I invoke that locally, it will print hello world. You see some output here, but this is not what we want. We want to create a Dockerfile. So again, we create a Dockerfile. So we are creating a base file. We are referring to a Ruby 2.5 base image here using the Alpine flavor. Again, this is the lightweight version. And you can see, well, if you try to set up Ruby yourself and a gem install Sinatra, this can already take an hour or two if you run into some stupid issues when downloading Ruby, or because it interferes something in your system. Like, it can be really tedious. So in this particular case, we are just using the base image where Ruby is set up properly. We are creating an application directory. We run gem install because we need the Sinatra library. They are called gems in Ruby. And then we copy the local file, which we've created earlier, to the application directory. And because the application directory is set as the working directory, all we have to do is call Ruby with our file name as a parameter. So let's give it a shot. I cannot execute that directly. First, we have to create the container image. So docker image build -t, giving it a name and a tag, and also saying that we are applying this in our local directory, which is essential because this is how the relative path of the copy command will work. See? So you basically tell this, apply this to the local directory, and then you're saying, well, I want to have copied the simple file, simple Sinatra app file, to my app directory. And this only works because I tell Docker to build the image from the local directory. Otherwise, this reference here in the copy would work. So you can see now it's downloading the Alpine image, which will take a little time, but because it's an Alpine version, that shouldn't take too long. Yeah, we're running gem install. And there we go. There we go. There are a few things that you could do wrong with gem install, because if you don't parameterize that correctly, then it usually generates you a lot of documentation, which will take an eternity, making your deployments very slow. This didn't happen here. Maybe it's already been taken in the Ruby base image, because that's what you get. You know, like, you're deploying an application of a language, maybe you don't know that language rather well, but you already get a lot of best practices by using such a base image, which is one of the big advantages of containerization, and in particular the aspect of standardization. All right, so again, we use Docker run. It's simple web app 0.1.0. Again, this refers to the local image we've created earlier. So the last time it told us where to find it. Localhost 4567. Paste that. Oh, that was a period. And it doesn't work. Why doesn't it work? Somebody? Why isn't this working? Come on, guys. You know the answer. We've done this before. Who doesn't know why it is not working? Well, now somebody has to say something because I asked, do you know it? Nobody said something. Now I ask who doesn't know it. And if you're all silent, I assume that you're already out for lunch.
Can you repeat the original question, please?
Why doesn't it work? Like I'm entering localhost 4567, which worked when running the application locally, but it doesn't work after starting the oh, well, this command failed. Unable to, yeah, I have a typo again. So now it's running WebRig 1.4.2. It says I'm running here on 4567 and I'm reloading and it doesn't work. Why not?
The ports are only binded within the Docker container, right?
Yes.
So it isn't accessible from the outside.
Exactly. The container shields the port unless you create explicitly a port mapping. So who remembers how to do that?
So it was only 4567 Doppelpunkt 4567.
Yes. So it's -p for port mapping, and if we don't want to, what should whether this will work already? Nope. Well, that's strange because this should work. 4567.
So sorry to interrupt you again, but I'm now leaving.
All right.
Well,
I think we'll. There's not much ahead for today, so you'll be fine.
okay, perfect. Thank you.
Bye-bye.
Bye.
So let's create a different port mapping, see whether this will work. Nope. Ah. the expose command is actually not meant to do anything. So I'm doing some kind of mistake. Need to figure out which one it is. Nope. Somehow the port mapping doesn't work. So the one is starting, the process starts, but it doesn't work. Could be a problem with the Docker itself, or I'm too stupid. One of both doesn't work. Huh, yeah, it says it still doesn't work. Ah! I tricked myself with my own trick. Ha! Stupid me. All right. So what's happening here is I actually intended that in the tutorial, but I forgot about it. So, so I just fooled myself. Damn you. I'm such an evil person. All right. So this is one of the issues you might encounter over time, but it is not as obvious. As you see that I even fooled myself with it. So it was the lesson that when I created the tutorial, I actually fall for it the first time. So I thought, well, if I fall for it and if it's not trivial for me to find it, it won't be for you. So I actually I usually do when I'm writing tutorials, I leave the errors I'm making in the tutorial, because sometimes they are common mistakes. No, not always, but at least sometimes. And this one is one of them. I will explain this one because it is not as obvious. Now, the problem is the following. The port mapping is there, and there's a web server running inside the container. Now, let's debug it together, right? I know what the problem is, but let's approach it systematically as if we didn't know. So we need to verify the chain that needs to work. So in order for that to work, we first need to ensure that the web server is running. Well, we see the web server is running. The question is the web server serving any requests. So we can use the trick that we have learned earlier to get access to that container, which we'll do now. So Docker container ls, and you see that. You see here's the application, and you can also see that here's a port mapping. So the port mapping is there. We can safely assume that this is the case, and this is our container name. So we docker exec interactively into that container and opening a shell and say PS. And here's our Ruby application. I think we do have a wget command, which is nice, because then we can issue a command with inside the container. So we're inside the container, we're asking localhost, and it's stored. Ah, damn, I killed the interactive session. But you can see down here that it got a request and it served it. Oh, I have to restart this shell. So, and here's my request. So the process serves requests, but the port mapping doesn't work, although the port mapping is set up. So what's the problem? And the problem is, I'm not sure whether I have ifconfig. Yeah, I do have ifconfig here. The problem is I have two network devices here. And that this one is a bridge networking, or a networking that is used for the port mapping. So the port mapping can only work if the process, the web server process, is bound to that interface. If the port mapping is bound, if the process of the web server is bound to localhost, to the loopback device, this is not reached by the port mapping, and that's the case. I'm not sure whether I have netstat here, but it basically tells me here that I have a Ruby program that binds to port 4567, and it uses the local, the loopback device. And that means it is not available for the port mapping. So the web server is running, it's serving requests, the port mapping is set up, but the mapping of the process, the binding of the process to the right network interface is not given. And this is one of the things that we need to fix. So we have to go back. We shut down the container because this needs to be fixed in the Sinatra code. So we edit our application. We add this little bind command. The special IP address 0.0.0.0 in most cases, it's not working everywhere, but in most cases means binding a process to all network interfaces. This is usually quite insecure. You should usually bind to only those interfaces you intentionally want to bind to. But in a container where we only have the two, it's okay to do that. All right, so in order to take effect, we now have to rebuild the container image. We're using the same tag here. If you'd already published the container image, you'd have to bump the last of the three versions, assuming that this is semantic versioning, where you have major, minor, patch level. Patch level would be I fixed something. Minor would be something like a small change, and a major release would have API breaking changes. Okay, let's rebuild the image. Let's run a container, and it works. Wonderful, isn't it? All right. This is basically it for the first lecture. We did it on time. I'm glad for that. Takeaways. We've learned what a container is. It's not a virtual machine. It has some properties of a virtual machine, such as isolating processes with respect to CPU and memory. We've also learned that the isolation is weaker, as it uses different methodologies and methods to isolate. It's using C groups and namespaces. It does not come with its own kernel. So there's limits to it. We have seen that there's a very particular way on how container images work. So a container is based on a container image. We have seen that container images are based on a layered file system that can be created with Docker by creating a Dockerfile, which is rather simple. We've seen that we can, well, we'll publish an image in the next lecture, and but we've also already pulled images. From a container registry. We've seen the purpose of the container registry, which is to distribute and share privately but also openly container images. We've seen the power of having good container images, because it reduces the stress and the effort for packaging applications such as a Go app and a Sinatra app. So we use 2 different languages today. And while the applications were pretty simple, setting up a language environment and an environment to run a Sinatra application, for example, usually is involving a bit more time than just referring to a base image. We've seen that using the concept of container images is rather handy. It's useful. It saves time. We've seen that container images and resulting containers can be started and stopped, but that if you're looking into a container orchestrator, containers won't be restarted, they will be recreated. And when they be recreated, you lose the entire state of the container. That's why persistency is going to be something that we'll have to look at some point. Now, in the next lectures, we are looking into how we would publish a container image, and then look into the container workflow. I think we have 4 minutes left. So maybe I'll show briefly how you publish a container image, and then we can close the container topic and start with Kubernetes in the next lecture.